In this video, we're going to be looking at the naming system that specifically applies to ionic compounds that contain transition metals. Now, for those that don't remember, transition metals are the metals that are found in the middle of the periodic table, such as the ones that we see here. And on the periodic table, we can see that all of the transition metals separate the alkali and alkaline earth metals from the nonmetals on the right-hand side of the table. Now, the details involving transition metals that make them a little bit more complicated to name when they are part of ionic compounds has to do with their charges. For example, if we take a look at the element iron, we can see that unlike the alkali and alkaline earth metals that only have one specific charge, iron is an example of a transition metal that actually has multiple charges. So we can see that iron can form an ion with a positive 2 charge or an ion with a positive 3 charge, and there are even some transition metals that can have up to 3 different charges depending on the type of compound that it's in. Any transition metal that has the ability to form multiple charges as an ion is what we call a multivalent transition metal, and here we can kind of see the reference to the word valence, referring to the electrons that are farthest away from the nucleus that metals lose. What this means is that depending on the transition metal, transition metals might be able to lose a different number of valence electrons depending on which nonmetal they are paired with. Just to prove that different compounds exist with the same transition metal, we can see the chemical formulas FeO, Fe2O3, and Fe3O4 all contain iron and oxygen, and we can see that all 3 of these ionic compounds involving just iron and oxygen look very different as well. This is why it's very important for us to be able to distinguish what the charge of the transition metal is. The good news when it comes to naming transition metal containing ionic compounds is that there's only one additional step. So the first thing that we can do is we can name what the metal in the compound is, and in all of these examples here, we're dealing with the transition metal iron. Now, the next thing that we need to do is we need to use the chemical formula in order to identify the charge of the metal. So in this case, this is where our nonmetal is going to be a big help to us. So we remember if oxygen is in group 6, that means that it has 6 valence electrons, meaning that gaining 2 is easier than losing 6. And when oxygen gains 2 electrons, that means that it is going to have a charge of -2. Now, if we remember that all ionic compounds need to have a neutral charge, that means we need a positive charge on iron that will cancel out a charge of -2. So if we designate iron's charge as being +2, we can quickly check if this works. +2 minus 2 is equal to 0. So that shows us in FeO, iron must have a charge of +2 in order to produce a neutral charge when bonded to one oxygen. Now, the way that we identify the charge in the chemical name of FeO is using Roman numerals. So the same numbering system that is used to identify group number is also used to identify charge. So in between the name of the metal and the nonmetal is where we put the Roman numeral. And because iron has a charge of +2, we put the Roman numeral 2 in here like this. And then the rest of the naming system is identical to every other ionic compound. So the next thing that we need to do is we need to name the nonmetal. We've already looked up the name of oxygen, so we can just write the word oxygen here. But remember that whenever a nonmetal is part of a compound, we need to remove the suffix. So in this case, we're going to remove the -gin part of the suffix and replace it with IDE to identify that oxygen is a negatively charged ion that's part of a compound, and now we have iron, Roman numeral 2 oxide, is the way to identify FeO. Now, before we end this video, just as a point of contrast, if we were to take Fe2O3, a different form of iron oxide, we can see how the naming system would be different. So the good news is that the metal name and the non-metal name are identical because iron and oxygen are still the two elements. The only thing that would be different is the charge. Now, this is a little bit different, but here we can use some simple arithmetic in order to find what the charge of one iron is going to be. So as we've already established, because oxygen gains 2 electrons to form an ion, it's going to have a -2 charge. But unlike with iron 2 oxide, this compound here has 3 oxygens instead, so 3 times -2 is a total negative charge of -6. Now, in order to get a neutral charge of 0, that means we need an equal amount of positive charge. So that means that all of the iron in Fe2O3 need a total positive charge of +6 to cancel the negative charge and get a neutral charge for the whole compound. The problem is that we don't have one single iron, we actually have 2. Well, that's not actually a problem because we can take the total positive charge of 6 and divide it by 2 iron atoms, so +6 divided by 2 is +3. So what this means is each iron has a charge of +3, and since there are 2 irons, that's a total positive charge of +6, and we would label this compound as being iron 3 oxide instead. And using our periodic table, we can see that +2 and +3, the Roman numerals that we identified, are the most common charges that iron is able to form, and that confirms that our naming system for both of these iron oxides is indeed correct. This concludes our series on ionic compounds. Before you move on to the next video series, which deals with covalent compounds, you can try the practice problems below, in which you will need to either name or determine the chemical formula for ionic compounds that contain a multivalent transition metal. And before you move on to covalent compounds, you can try the comprehensive review questions below that cover all aspects of ionic compound structure and the naming system as well.